We have two algebraic strategies for solving a system of equations. Our first algebraic strategy is called substitution. Substitution requires us to solve one of the equations for one of the variables and then substitute that information into the other equation. When you're given a system and asked to use substitution, it's best to take a look at the entire system together and identify the variable in the system that would be the easiest to solve for. In this case, it's fairly straightforward. This x is almost all by itself already. So that's the best candidate to be solved for. We rewrite the equation as x equals -4 minus 4y, and that information will get substituted into the place of the x in the other equation. Careful not to substitute it into the equation that you just took it from, as that would create a 0 equals 0 situation, which is not going to help you solve anything. So we sub it into the other equation, and we let -4 minus 4y take the place of the x. And the rest of the equation stays the same. We'll distribute in order to simplify the left-hand side. We're going to add 12 over and combine the two y's. So we're left with -7y is equal to 14. Divide by -7, and we get y is equal to -2. While it would be really nice if that was the place that we were done, we of course are not finished yet. We need to substitute that information back into one of the two original equations and figure out what x is. There really is no wrong place to put this particular y. You could put this y in this equation, you could put this y in this equation, and you could put the y in this equation. All of them should give you the same answer. However, because you did just work with 3x plus 5y equals 2, it's probably a good idea to not use that one. It doesn't mean it wouldn't work, but it's a little bit easier to catch mistakes if you try to back substitute that number into one of the other equations. For the sake of simplicity, it's oftentimes easiest to substitute it into that equation. Again, it leaves open the door for a little bit of if you made a mistake, it wouldn't necessarily catch the mistake because you're subbing it back into something else you used. But for the sake of expediting the process of solving a system by substitution, it's a fine place to sub the variable. So we'll say x is equal to -4 minus 4 times -2. X is equal to -4 plus 8. X is equal to 4. And we remember that this solution is a coordinate pair. This is a location on a graph of these two linear systems. So when we write our answer, we make sure we write it as a coordinate pair. Now, if you want to convince yourself that you did this correctly, you can always back substitute the numbers into both equations and check that they work. 3 times 4 plus 5 times -2 is 2. That's a check. 4 plus 4 times -2 is equal to -4, and that is also a check. So just to recap, the process that we use to solve a system by substitution is to solve one of the equations for one of the variables, substitute that solved equation into the other equation. That creates one equation with one variable instead of us having two with two. Then we solve that new equation, back substitute, and check our answer.